Hello everyone, this is Dr. Jenkins. Here we are for our first online video. So I know I keep saying it, but I just want to make sure everyone understands. We're clear. We're going to meet in person every Wednesday and Friday. And then in place of meeting every Monday in person, you are to watch a video. So here's our first video. Make sure that you watch this, take notes, and study before our next meeting next Wednesday. So what I want to do is I want to finish chapter 1, which won't take very long, and then start chapter 2, okay? As always, I'm going to be covering what's most important and letting you know what to focus on versus what you may not need to know. All right, here we go. So for what we finished off in lecture was we were talking about having a common language, terminology that everybody in any health-related field can understand. So we talked about general terms like directional terms, anterior, posterior, medial, lateral. And then we talked about planes of the body. And now I want to introduce a couple of other things. So here we go. It turns out that all of our insides, all of our organs and such, are housed in 2 body cavities. We have a dorsal cavity. We already know from our previous lecture that dorsal means back. So all of our organs that are on the back part of our body are considered to be in the dorsal cavity versus the organs that are housed in the ventral cavity. And we may remember that ventral means front. I know this sounds kind of simple. I'm going to go ahead and do a picture, okay? Dorsal and ventral, back and front. In this picture, everything that is red is considered part of the ventral cavity versus everything that is yellow. I wanted to use this one. Everything that is yellow is part of the dorsal cavity. Now, why are we even talking about this? It's because these things are there for a reason. Imagine if, we wouldn't do this of course, but imagine if we took out all of our organs. If we took everything out, we would have these empty cavities, but these empty cavities are separate. We don't want all of our organs just thrown in together. So there's 2 main benefits. One benefit is that we want to house organs that work together near each other. Wouldn't it make sense to put the heart and lungs in the same cavity? Because they work together. So this helps us to put organs that work together in the same region. Another benefit is that it keeps things separate. What if you have an injury or damage to one area? By doing it this way, it means that you're not necessarily going to have damage everywhere. Let's just say, for example, a ruptured spleen. That can be really dangerous in itself. But if we have a ruptured spleen, the bleeding from that can be somewhat contained in the ventral cavity, as opposed to if it was all thrown in together, we might see that damaging our spinal column. So just know our 2 main cavities, ventral on the front and then dorsal on the back. You will also need to know that these cavities have subdivisions. On the ventral cavity, there's a thoracic subdivision, and we're going to group together the abdominopelvic. So we have 2 subdivisions, thoracic, and of course in the thoracic is where we have our heart and lungs, and then abdominopelvic. We're going to group these together, abdominopelvic. This is where we have our abdominal, our GI organs, and our reproductive organs. So they're both part of the ventral cavity, front, and the ventral cavity has 2 subdivisions, thoracic and abdominopelvic. We're going to see this in the rat. Next week in lab, we're going to be dissecting the rat. And even though you may not realize it, one good thing about the rat is that their organs are arranged in a similar fashion as to us. So when you open up the rat, you're going to see the ventral cavity on the front, and you're going to see the thoracic separated from the abdominopelvic, arranged just like us. I want to point out one last thing on the ventral cavity, and that is the diaphragm. So the diaphragm is this respiratory muscle, and the diaphragm separates the thoracic subdivision from the abdominopelvic subdivision. Cool. Then we look at the dorsal cavity. That's on the back, and the dorsal cavity has two subdivisions. The cranial cavity, which of course contains the brain, and the vertebral cavity, which of course contains the spinal cord. So make sure you review these body cavities or subdivisions and what organs are housed in each. You don't need to know any of the other specifics. So some of these pictures get a little bit more detailed, but you only need to know what it is I just talked about. Now, when it comes to the abdomen, there's just so much going on in the abdominopelvic cavity of the ventral cavity. There's just so much going on. So because of that, it can be helpful to separate just the abdomen into separate regions. These are not completely new cavities or subdivisions. It's just these theoretical regions. You don't need to know the 9-region system. So it's possible to divide just the abdomen into these 9 regions. You don't need to know this. A surgeon might use this. Instead, I would like you to know the 4-quadrant system. So when it comes to the abdomen, you're going to need to know what organs are housed in each, what we call, quadrant. These quadrants are all based off of the belly button. Did you know, folks, the fancy name for belly button is umbilicus? Kind of a funny name. That's the fancy word for belly button. But check it out. The belly button serves as separating the upper abdominal quadrants from the lower abdominal quadrants. And then the belly button is also the divider between the left abdominal quadrant, left of the belly button, and then the right of the belly button. Keep in mind, it's left and right as it would be on that person. When you look at this screen, what appears to be on the left is actually our right, but we name these by what it is on that person. So this would be that person's left side. This is this person's right side. So you need to know the major organs, and again, we're still only in the abdominopelvic cavity, abdominopelvic. But you need to know the major organs that are in each. Let's first start with the upper left quadrant. Actually, we'll do upper right. Upper right has the liver, and then the gallbladder is right below it. So upper right, liver, gallbladder. This can be helpful just so we know where it is. But also, what if someone has pain in the upper right quadrant? Well, then we can be pretty assured that it's something that has to do with the liver. Whereas if it's the upper left quadrant, this is where we see the stomach. Then the spleen is over here on the side. So upper left quadrant, stomach, and spleen. The lower quadrants have the small and large intestine, obviously. Of note, I want to point out the lower right quadrant has the appendix. That little dangly thing is the appendix, lower right. So if someone had sharp pain in their lower right quadrant, we might think it is appendicitis. If it was a similar sharp pain in the lower left, we probably wouldn't think appendicitis because that's not where the appendix is. For now, I'm going to have you not worry about the pancreas. We're going to talk more about that in lab when we have the model. The pancreas is more so on the upper left, but it does extend a little bit to the upper right. But for now, don't worry about that. All right. Remember, you don't need to know the regional terms. I want to end this chapter by just reminding you that knowing what a prefix or suffix means can help you understand the meaning of an entire word. You don't need to know these for an exam, okay? I'm just throwing this out because I want you to learn how to try and use the parts of the word to help you know what the whole word means, okay? You don't need to memorize these, but as we go through the A&P 1 and 2, you can start to be able to figure out what words mean, okay? Some of these you probably already know. You may know that the prefix osteo means bone, osteoporosis, weakening of certain bone tissue. Some of them you may not know. Chondro means cartilage. Hemo means blood. Rhino is nose. Maybe if you've seen, I'm not on social media really, so I don't know, like rhinoplasty. Back in the day, we used to read Us Weekly magazine, and you'd read about a rhinoplasty of a certain celebrity. Rhinoplasty is a nose job, but rhino means nose. Histo means tissue. Hypo means less than. You don't need to memorize these. I'm just trying to encourage you as you learn these to start being able to break words down. And the same thing can be said for suffixes. Ology means study of. Biology, study of living things. Ectomy means removal. Appendectomy, removal of the appendix. Osis means condition. Class means to break down. So you don't need to know these, but as we start to move forward in the semester, pay attention because you can start to understand words just by the prefix and the suffix. To that end, folks, to that end, you're going to see this semester, I'm going to be posting some practice. Let me erase these. I was working on it earlier. I'm going to be posting some practice assignments. These are not worth any points. I'm going to post this on Brightspace for you. These are not worth any points. It's not extra credit. But if you're looking for things to help you with the material, I encourage you to do these. For this one, if you choose to do it, it can introduce you to what more of these prefixes and suffixes mean. So on the left here, we have a list of prefixes. Sometimes I've given an end part of the word that might help you. And then on the right is a listing of the possible answers. So if you want to do this, you can match them up. Let's see. Like neuro. Neuro as a prefix. Of these on this page, which one of these means neuro? I think you already know that, don't you? So wouldn't that be nerve? So if you want to, go ahead and do some practicing, matching them up. There's more prefixes on the second page here and then some suffixes. These will not be on it. These won't be on an exam. It's not for credit, but if you want to get ahead and practice, you're more than welcome to do these. And you're going to see these throughout the semester. I will post the answers shortly. So after you do them, you'll be able to see the answers to see how you did. And by the way, don't Google these. That's not the point. The idea is to look at the prefix or suffix and think, and then try and pair it. All right, here we go. Let's start chapter 2. Okay, chapter 2 is on chemistry. Usually this tends to be one of the, let's just be honest, this tends to be one of the least favorite chapters. It used to be that chemistry was required in high school, and I don't know if that's the case anymore. It certainly was when I was in high school, but that was a long time ago. In any case, what we're going to be doing is we're just going to be reviewing or introducing some of the basics. Because when we go on to later chapters, we're going to have to understand what some of these chemical things mean. So don't worry, I'm here to help. We're not going to get that detailed, but you've got to think about where you are. If you've had chemistry before and you have some familiarity, this probably won't be as difficult for you. Then you just play along, review, okay? But if you haven't had chemistry, then you're going to have to spend more time with it. All right, here we go. I want to introduce this today, and then we're going to finish it in person. These are going to be some of the important concepts we're going to use later. So you can't play ice hockey until you learn how to skate. Same thing. We can't understand a nerve impulse conduction or a muscle contraction without understanding some of the chemical properties. We are just going to introduce things, folks, but I'm here to help. All right, let's just start with some basic definitions. Make sure that you can define matter. Matter is anything that takes up space and has mass. We have matter in solid, liquid, and gas forms. So this is just in the universe, there's different types of matter, solid, liquid, gas. We also see all three forms of these matter in our body, right? So don't take this to be too serious in terms of trying to understand it, but just know that we've got these in our body. You know we have solids, bone tissue, organs, nervous tissue, our brain. We have liquids. The obvious example of a liquid in our body is blood, but we have plenty of other liquids. You could think about the cerebrospinal fluid surrounding our brain. We could talk about synovial fluid, which is a fluid in our synovial joints to reduce friction. We could talk about the gastric juices and saliva in your GI tract. And we, of course, have gas, oxygen, carbon dioxide being the two biggest. Now, remember, looking ahead, your exams are going to be multiple choice. So you're not going to have to write a definition out on your own, but you should be able to choose the proper definition from a list. What if I said on an exam question, which of the following is the correct definition of matter? You would choose the one that says something like something that takes up space and has mass. Then we move to smaller components of matter. Elements. Elements are unique substances that make up matter, but more importantly, they cannot be broken down by normal means. So again, just be able to pair each of these with their correct definition. An element, a unique substance that cannot be broken down by normal means. I know everyone has heard of and or seen the periodic table of elements. You don't need to know the periodic table of elements. You should feel good about that. Again, be able to pick from a list the proper definition. What is an element? A unique substance that cannot be broken down by normal means. Now, you don't need to know every single element, of course, but I am going to point out one thing. It turns out our body is made up mostly of the same 4 elements. Isn't that crazy? Oxygen, carbon, hydrogen, and nitrogen. These 4 elements make up over 90% of us. That's crazy. The way that I remember these 4 is I make a mnemonic device. So if you do CHON, cone, our body is made up of the most of which 4 elements? Cone, carbon, hydrogen, oxygen, nitrogen. So you should know that. Now, of course, we have other important elements in our body that are just as important. But I'm just saying in terms of quantity, what we have the most of, carbon, hydrogen, oxygen, nitrogen. Look at us moving along. Be able to match the definition. We got matter, we have elements. Now I want to introduce atom. Atoms are the smallest particles that make up elements. Atoms are the smallest particles that make up elements. And what you're noticing here, hopefully, is that we're building from small to large. So atoms are the smallest particles. Together, atoms join together to form elements. And then elements form together to form matter. So we're building from the smallest pieces, the smallest chemical pieces of us, atoms, which form elements, which ultimately form matter. All right, let's talk about atoms. Before we do that, You don't need to know the specifics of any of these elements here. I'm not going to ask you about atomic number or any of that. You only needed to know what I just talked about. You also don't need to know about isotopes. Feels good to cross things off, doesn't it? Haha. Okay. The last part of this video, I want to make sure that everyone understands the basic structure of atoms. Okay, so we already know that atoms are the smallest particles. Great. Well, let's talk about the parts. I'm hoping some of you have had this before. But again, if you haven't, you can totally do it. You're just going to have to take some time. And just make sure that you, excuse me, something in my throat. Just make sure that you put enough time in to understand this. So let's talk about the structure of an atom. I've put in a rectangle helium. I'm not going to ask you to know the specific structure of each, like what does helium look like versus lithium, but I'm going to use helium as an example. So let's first identify the two main structural parts of an atom. An atom is made up of two structural parts. There is, and I'm going to use colors. Let's see, let's use green. Okay. The nucleus, that's too bright for me. Woo. The nucleus is one part of an atom. Nucleus, you probably know, means the center. So let's look at helium. Each atom has a central part, and that's called the nucleus. And then, let's use blue. Outside of the nucleus are these outer shells that I've put in blue. We tend to call them electron shells, so outer electron shell. Each atom has two structural parts. Let's look at lithium on the right. One structural part of an atom is the nucleus, and then the nucleus is surrounded by these outer electron shells. Sometimes there might only be one electron shell. Sometimes there might be more. This one has two. But in any case, it doesn't matter. Every atom has a nucleus in the center and then an outer electron shell. Folks, this isn't so bad, okay? I'm introducing this in a way that I think is best to learn it. We're going to be learning it in steps. So we first understand what an atom is. It's a smallest part of us. Each atom has two structural parts, the central nucleus, and then surrounding that central nucleus are electron shells. Start there. Now, after you understand that, now we're going to take it to the next step. Now we're going to identify where we find the three subatomic particles. So each atom has three subatomic particles: protons, neutrons, and electrons. Let's talk about where these are and what charge they have. Let's first look at protons. Protons are in the nucleus. Here, they're red. I'm going to circle it in as green, but here are the protons. So protons are found in the nucleus. Protons are found in the nucleus, and they have a positive charge. So we have three subatomic particles: protons, neutrons, electrons. Protons are found in the nucleus, and they have a positive charge. Next, let's look at neutrons. Neutrons are also in the nucleus. I'm going to circle them in as red. Neutrons are also in the nucleus, and they have no charge. These colors together look like Christmas, the red and the green. Neutrons are also in the nucleus, and they have no charge. They're neutral, as the name suggests, right? Proton, pro, p, positive. So in the nucleus, we have protons and neutrons. Then, in the outer electron shells, we have these black circles. I'm going to circle them in as blue. These are our electrons. So electrons are located in the electron shells, and they have a negative charge. Electrons are located in the outer shell, and they have a negative charge. Now, your everyday atom has the same number of protons, neutrons, and electrons. There's always going to be variations and exceptions, but for our first understanding, a typical atom has the same number of protons, neutrons, and electrons. Let's just look at helium. That's been our example anyway, right? Helium happens to have 2 protons. Protons are positively charged. 2 neutrons, no charge. And 2 electrons, negative charge. So, your everyday atom has the same number of protons, neutrons, and electrons. Now, what would the overall charge of this atom be? If we have 2 things that are positive, 2 things that are neutral, so we can more or less forget about that because it's neutral, doesn't affect the overall charge. So we have 2 things that are positive and 2 things that are negative. What is the overall charge of this atom? Neutral. Because your everyday atom has the same number of protons, neutrons, and electrons, we have 2 positive things and 2 negative things. The overall charge is neutral. Everything else on here, you don't need to know. If this is new to you, it might be a lot, okay? So you're going to have to put the time in. But if you follow along with me step by step, you can absolutely get this, okay? Now, there's some extra rules that we have to talk about. One of them, well, all of these in particular, relate to the electron shell. So we already know that an atom has 2 parts, the inner nucleus and then the outer electron shell. We know that the inner nucleus contains, let's go with black. The inner nucleus contains protons and neutrons, and then the outer shells have the electrons. That's just a review. Okay, good. Let's talk more about these outer shells. The first electron outer shell can hold a maximum of 2 electrons. That's it. The first shell can hold a maximum of 2. Let's look at hydrogen. Hydrogen is this one. Hydrogen has 1 electron. Hydrogen has 1 electron. So we form 1 electron shell, and then we fill that electron shell with our 1 electron. Now, what if we move to helium? Helium has 2 electrons. So again, we form our electron shell, and then we put 1 electron and 2 electrons. Great. What if we have an atom with more electrons? Let's say we start with lithium. Again, you're not going to have to know these specifics. I'm just using this as an example. Lithium has 3 electrons. So we go through the same process. we start with our first electron shell. We have 3 electrons, so we put 1 and 2. We still have a third electron to put, but that first shell can only hold a maximum of 2. Therefore, we have to build another electron shell. So we fill the first one with 2. If there's more, we build another electron shell. And now we've added our third electron. Now, each additional, you're gonna have to bear with me for one moment. I'm recording this and it's starting to rain, so I gotta close my windows. Let me just do this real quick. Okay. Each additional electron shell can hold a maximum of 8. It's only that initial one that can only hold a maximum of 2. But every additional shell can hold a max of 8 electrons. This is sometimes called the octet rule. Every additional shell can hold a max of 8. So let me just go ahead to another example. Again, you're not going to have to know these atoms specifically, but I'm just using them as an example. Let's say that let's use carbon. I'm never going to ask you to build these out. I'm just using this as an example. You do need to know how many electrons each shell can hold. So the first electron shell can hold a maximum of 2 electrons. Every additional shell can hold a max of 8. Let's just go through an example to help understand this. Carbon. Carbon has 6 electrons. So let's build out 6 electrons. As we know, our first electron shell can hold a maximum of, Our first electron shell can hold a maximum of 2, right? So we put 1, 2. But we have to do 6, so we still have 4 more. So now we're going to build another one. So we do 2, 3, 4, 5, 6. For that one, we only needed 2. What if we go down now to sodium? Sodium has 11 electrons. So, same procedure. How many maximum electrons can that first valence shell hold? 2. I do 1, 2. I have 11, so I got to do more. So now we're going to add a second electron shell. So we started with 2. Now we're going to do 3, 4, 5, 6, 7, 8, 9, 10. I have 10 electrons. I still need 1 more. So now we have to build a third electron shell to add our 11th electron. So that's how it works. Last thing before I end this video, I'd like you to have an idea of when atoms are the most stable and when atoms are the least stable. You don't need to know the specific words inert or not even reactive, but let's just talk about most stable versus least stable. Okay. It turns out atoms are the most stable when their valence shell is full. Most stable when that outer shell of electrons is completely full. Let me go back for a second. Valence, that's just the term we use. A valence shell is whatever the outermost shell is. No matter if an atom has 1 electron shell or 10 electron shells, doesn't matter. Whatever that outermost shell is, whatever the outermost one is, that's considered the valence shell. So atoms are most stable, dare I say, even happiest, Atoms are the most happy when the valence shell is full. Look at neon. Neon has 10 electrons. So we build, I'll use green, easier to see. We build our first electron shell, and I fill it with the maximum of 2 electrons. Then I build another shell, 2, 3, 4, 5, 6, 7, 8, 9, 10. Boom. This is what neon is, 10 electrons. This is a stable, happy atom because its outermost shell is full. What is the max number of electrons that this shell can hold? 8. Remember, the max number of the first electron shell is 2. Every additional electron shell holds a max of 8. And this outer valence shell has 8. Atoms are most stable when their valence shell is completely full. So on the other hand, atoms are least stable, or some might say unhappy, when their valence shells are not full. Let's look at carbon, which I think we already did, right? Carbon has 6 electrons. So we fill the first valence shell with 2. Then we have to build we fill the first electron shell with 2. And then we add another one, 2, 3, 4, 5, 6. I've satisfied because it has 6 electrons. However, is that valence shell full? The valence shell has 1, 2, 3, 4 electrons. The valence shell has 4 electrons. What is the maximum number it can hold? 8. So it is not full. Therefore, this would be considered a least stable or an unhappier atom. And because of this, these are the atoms that are most likely to participate in chemical reactions. Most likely to be in chemical reactions. That's why we care about this. This is going to dictate how these atoms act. Atoms that have a full valence shell are really stable, very much less likely to participate in chemical reactions. Atoms that have an incomplete or a not full valence shell, they will be most likely to participate in chemical reactions. All right, we're going to pick up here when I see you next. Please make sure you watch the video, take your time. I will have expected that you watched the video, took notes, bring your specific questions. All right, see you next time.